Question 10 is about isomers of C6H10O2. We've got one of the isomers P here, and they want us to name it. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's pent. There are 5 in a line. Pentanoic acid, except it's not an anoic acid, it's not an ane, it's an ene. Pentenoic acid. If the carboxylic acid group is at number 1, then the enoic acid, the ene bit, is at carbon number 2. So pent-2-enoic acid. The ene, E-N-E, and the O, I need to drop the E. So it's pent-2-enoic acid with a methyl group at number 2 as well. And it looks like it's a Z isomer because of I've got no free rotation about the carbon-to-carbon double bond. And so I've got 2 different groups to the left of the carbon-carbon double bond. I've got 2 different groups to the right of the double bond. It's got geometrical isomers. If I trace from this C, H has got an atomic number of 1. The C bonded this way has got an atomic number of 6. So this group here, this ethyl group, takes priority. To the right, I've got a carbon, atomic number 6, and I've got a carbon, atomic number 6 both ways. So I carry on down the chain. Hydrogen with an atomic number 1. After the carbon, I've got an atomic number, an O with an atomic number 8. So this one takes priority, so it's Z. So my answer is Z. 2-methyl. So this is carbon number 1 on the carboxylic acid group. The methyl's on carbon number 2. Pent-2-enoic acid. I've dropped the E after the ene so that I don't end up with 2 vowels together, an E and an O for the enoic acid. The sample of P was mixed with excess oxygen. The mixture was ignited, so P's going to be ignited. Excess oxygen, so it's complete combustion. I'm going to make carbon dioxide and water. I'm not going to make carbon monoxide or carbon with incomplete combustion. I've got plenty of oxygen. After cooling to the original temperature, the total volume of gas remaining was 335. I'm just going to skip, write an equation for the combustion of P. I'm going to have a look and see what it is. So I've got C6H10O2. And I've got 7O2. I'll work out why I've got 7.5 O2 in a minute. I'm going to make CO2 and water. The best thing to balance first, 6 C's, so I'm going to need 6 CO2. I've got 10 H's, so I'm going to need 5 H2O. 5 2's are 10 to balance the H's, and therefore I've got 12 O's plus 5, 17 O's. I've got 2 there, so there's 15 in this. That's why 7.5 times 2 is 15. Now, it tells me that after cooling the original temperature, that means that any water has now condensed back to room temperature, back to 25 degrees C. So there's 2 gases left in the system. There's carbon dioxide and there's any leftover oxygen. It says, after this gas mixture has passed through sodium hydroxide, the carbon dioxide reacted and the volume of gas decreased to 155. So it's come down from 335 to 155. And it's because the carbon dioxide's been removed. So if I subtract those 2 numbers, I work out I've got 180 centimetre cubed of carbon dioxide. Now it wants me to do something with this carbon dioxide. Clearly, it's given me a gas constant. So it'd only be giving me a gas constant if it wanted me to use PV equals nRT. So, have I got a pressure? Yes, 105 kilopascals. It needs converted into pascals. A large unit, like a kilopascal, is down into a smaller unit and multiplied by 1,000. So 105 kilopascals is 105,000 pascals. What else do I need? I need volume. Well, I've got volume, 180 centimetre cubed. But I need to convert that into meters cubed. So, to turn small into large, centimetre cubed into decimetre cubed, I divide by 1,000, so that will be 0.180, and then to get decimetre cubed into even larger, meters cubed, I divide by 1,000 again. So it turns out to be 180 divided by 1,000 divided by 1,000 again. It turns out to be 0.000180 meters cubed. So I've got P, I've got V, N number of moles I won't know, R is the gas constant, I'm always given that 8.31, and temperature needs to be in Kelvin. It tells me there temperature's got to be in Kelvin, and I've got temperature in degrees C, add 273, so that's 298. So I put all the numbers in and multiply some of them out. 18.9 now equals N multiplied by 2476.38. N is the number of moles of carbon dioxide. We've got to remember that because we've worked out it for the volume of carbon dioxide. So N is the number of moles of carbon dioxide is now 18.9 divided by 2476.38 equals 0.007632. I've worked out the number of moles of carbon dioxide. So I've got quite a lot of these marks now already. I've probably got 3 or 4 marks already. Now it says it wants me to work out the mass of P used. Well, in my equation, 6 moles of carbon dioxide are made when 1 mole of P, this chemical P, C6H10O2, are reacted. So if I've got 0.007632 moles of carbon dioxide, the amount of P used, C6H10O, must be a sixth of that. So I'll take this number and I'll divide by 6, and now it works out as 0.001272 is the number of moles of P. Now I've got the number of moles of P, I can work out the MR of P. Every carbon's a 12, every hydrogen's a 1, every oxygen's a 16, and the MR will come out to be 114. So moles is mass divided by MR. Moles, I've just worked out the number of moles of P by dividing the number of moles of carbon dioxide by 6. 0.001272 equals the mass of P divided by 114. So the mass of these two numbers multiplied together, 0.145 grams, except finally it wants it in milligrams. A large unit down into a smaller unit and multiplied by 1,000, 145 milligrams.